Thank you very, very much. Lovely to be here in Berlin again. We've had a couple of few years back, we had FableConf here in Berlin. It was a wonderful time. I was thinking in some of the conversations, I've got to use one of these, don't I? Is this on? It is, good. Yes, so I was thinking in some of the conversations, F# adoption or use has sort of four main kind of clusters. Since we're at a data science conference, we can talk about clusters and things. Then there's a server-side use of F# for cloud programming. For instance, implementing cloud functions or services of various kinds. I was just having a conversation with the Hack and Craft folk about their kind of use for F# on the server side. There's also the use of F# on the client side. For Fable and for building user interfaces and mobile programming with Fabulous and things. And then there's F# for data science, which is where this wonderful community we have together here. And then there's sort of F# for compiler and tools, which is for implementing F# itself and a whole range of compiler and tooling. And we have some people here from the F# compiler and tooling community, and in fact from those other communities as well. It would be awesome to see. I think it's so good to have an F# conference which is situated around one of those clusters in F# for data science, because and then you could easily imagine there being four such conferences. One, F# on the server side, or maybe F# for the full stack for both client and server, and then we have these sort of F# for sort of compiler and tools needs a community presence as well. But the thing that unites all of these themes is this love of clean and robust and performant code that it's not just about it being succinct. I think somebody on Twitter just today kind of said, it's not about being succinct. It's about what that succinctness brings in the way of clarity and what it does for teams who work together using F# as a communication mechanism. The code becomes a means of communication for a team. So we're sort of these four communities. We overlap with lots of other communities. The F# community has always been very open in kind of embracing concepts and ideas from other communities and being situated in actual practical programming, as you see in the data science work. We have professors coming up here and giving talks, and they're not just giving abstract talks, they're giving hands-on practical, how do we code and make stuff in these various domains so that it is simplified and so that we can get on and do the real science that we're doing and focus on that as well. And that's just a wonderful practical ethic that underlies these sort of communities that we have. So my role, I started F#. One of the main reasons I started F# is just because I love the kind of programming that it represents. And Isaac Abraham, who's here somewhere. Isaac, where are you? What's that? Bathroom. He's gone to the bathroom, so he's running. He says this data and functions thing that is at the core of F# programming, the cleanness that it brings. That you can go down the rabbit hole of functional abstraction and using. There's Isaac. I just gave you a call out. You go down the rabbit. Yes, big call out. Yes. You can go down the rabbit hole of using functional abstractions and Uber monad kind of arrows and all these other kind of things you can do. But then you kind of eventually come back to data and functions at the core of your programming. And the same thing, you can go down the object-oriented rabbit hole of just modeling absolutely everything with inheritance and classes for everything. But then sooner or later, as you mature as a programmer, you come back to where you started, which is data, the simplicity of data and functions, and finding solutions to problems with data and functions plus types in order to sort of tame the complexity of that. So what's my role? I was kind of one of the people who initiated F#, and my role now is I'm the language designer, but I'm kind of I do that for notionally half my time, but it's taking less than half my time. And one of the reasons why it's taking less than half my time is we have a absolutely wonderful team of people. Now, there's sort of two groups of people I want to mention. One is the Microsoft F# team who are based in Prague. And I think Peter is here representing the team. Hey, Peter Timken over here. Please big call out to those people. They are, Peter was just commenting to me, like, he used to be an F# user, happy, life's great, using F# every day, and just going in and just feeling that as you're cruising down the freeway, you're thinking, what have I got ahead in the day? A day of F# programming, life's great, sort of thing. Now he's actually working on the compiler tools, and he's kind of faced with this big list of bugs about how F# doesn't work properly in these kind of corner cases here and there, and what do we do about that? So you're kind of getting the harder end of the show, but I really appreciate what that's like and the kind of hard work it is to progress that tooling, to implement new features, and amazing work that you guys do. So another thank you to you guys. So when I say the language design side of things is going well, an example of that is a feature that recently went into we'll be rolling out in the next versions of F#, which is using _.property as a shorthand for fun. Yeah, so some of you know how many characters you're going to save by typing, by doing that. I never landed that feature. There's a long thread on the language design thread about where we kind of have a discussion, and I say, yeah, the feature could be like this, and then well, maybe it should be like this, and other people comment, and it kind of meanders back and forth, and never kind of, and then I stopped. I stopped commenting on it, and I forgot about it. And then I realized that over the last few months, the community have finalized that. The design is great, perfect. Now, as I said, there's no perfect in this. You've got to make some trade-offs at some point in language design. They've finalized it, they've implemented it, they've tested it like crazy, and they've done it together. And so in some ways, I think me stepping back a little bit and just like letting you guys, girls, sorry to use a gender term, is like run with this is actually really going to pay dividends over the coming years in evolving F# as a language and progressing its tool chain and everything that involves. So as part of that, I would want to do a huge call out to the amazing community initiative, which is Amplifying F#. And we've got, I think, 3 people. We've got Florian, Edgar, and David. Is David here as well? You want to stand up, guys? There we go, these 3. Now yep, you can take it. These guys have done an amazing thing, and it's a real exemplar for how to work in voluntary open source contribution kind of space. It's not just what you've done, but it's also how you've done it from a human level, which is just really remarkable in that you've created this space, you've focused on enabling contributors to come in and learn and start working on the F# compiler and tools. Not just the compiler and tools, there's a whole set of associated tools with that. Phantomas is one of them, but there are other ones, F# formatting and other ones that kind of lie around that kind of space. As you also see in the rider tooling for F#, as one of the contributors to this effort. And if you want to get involved in that compiler and tooling kind of area that I said, those 4 zones, Amplifying F# is absolutely the way to do it right now. And take a look at how these guys do their communication and set up their kind of the invitations to participate and set up their sessions and record the sessions and allow the discussions to be surfaced so that people can participate in them. It's really, really a great lesson in that you guys are teaching us, and big thank you to you for that. So a huge shout out as well to FS Lab. Seen several talks on FS Lab. covered a little bit of its history, but I think a real point of contribution and sort of unifying the efforts in the space for data science, and really happy with you know, the way that whole messaging is set up, and the whole software kind of just kind of anyone, you know, the fact that one of the talks was come and write a library for FS Lab. It's an invitation to participate. And communities are based around participation and opening doors for other people to come and contribute. There's one part of that is F# does need, in a sense, we've realized over time F# needs a bit of a media operation. We got a lot for free from Twitter. The F# community used to be totally centered on Twitter. And that has, for various reasons you all know about, that dynamic is breaking down, and the world is, a lot of people have left Twitter, a lot of people feel uncomfortable about joining this X thing. And so that actually placed the F# community in a little, like a lot of communities worldwide, we lose that kind of Twitter had this feeling where communities could sort of blend in with each other. One day you're having a chat with a Scala person and some other people see some F# people, other people see some rage argument in some other community, and then they start commenting, oh, the F# people seem quite nice or something. And so it kind of flowed back and forth quite nicely. That's much harder to do now, but part of, we don't really know how to solve that fully. Part of what we're doing is this thing called F# Online, which me and Philip Carter and some other people are running, and that's just trying to get a set of channels where we can get F# information, community kind of information sort of shared. There are other things like F# Weekly. So if you've got any ideas, or if you've got a burning desire to be a kind of run a media kind of initiative around F# or contribute memes is one thing that I've noticed started to float around the last few days, or whatever else you want to do. Start making your TikTok videos, you know, where honestly, you know, thinking about what the media forms the youngsters are using, that would all be appreciated. And just get in touch with me and we can talk about, or just create the stuff and tag us on F# Online. And the last group I want to call out a big thank you to is there are a bunch of people here who are consultants, and what notes did I write here? And sort of actually you're making dollars and pounds and euros and everything else from F#. But you're also, a lot of you are also wonderful providers of F# professional level content. We're seeing quite a lot of that content here today. I won't particularly call that out because I'll forget someone and someone will tell me I shouldn't have forgotten them or something like that. But you guys know, people know who you are. And thank you for all the contributions you make in the context of your businesses as well. Okay, so F# for fun and for profit, we get that. Okay, so that's kind of the F# side of things. I've got these two hats at the moment. Half of my life is spent at this wonderful group of people. This is some of the happiest working times of my working life, I must say, working at this group called GitHub Next. And I'm going to talk about two projects from there that have both to do with AI and code. So who are GitHub Next? So GitHub is just big enough, I'd say, that we have a small applied research team who report directly to the CEO of GitHub, Thomas Domke. And our mission here, researching the future of software development. Some of the people who made Copilot are in our group. So some of the machine learning experts, we have Christoph here, who is in our group. Where's Christoph? Over here. And also contributes to F# lot compiler and tooling, as a lot of you know. Yep. And so we are a applied research group, as I said, reports to the top. And this is our mission. And yeah, so we have a build, release, learn, and cooperate kind of model. So very focused on actually releasing what we do. We're about 15. We're a mixed team. We have some machine learning experts, some from Copilot, some UX experts, and just some general CS experts. And I really like it because, I used to work in Microsoft Research, which Microsoft is, you might think is one thing. It's actually this huge company, right? And Microsoft Research is over here, and the rest of the Microsoft is over here in all their different divisions. And working across those boundaries was a very long boundary, and it was also an 8-hour time zone for me. This is difficult. When we started F#, and we'd worked on .NET generics and other things and other projects that we did, it was just difficult to work across these boundaries. GitHub Next is different. You've got GitHub, a smaller organization, and GitHub Next is tucked in alongside GitHub. So we're up quite close to this kind of wonderful thing, which is GitHub, which is at the center of so much software collaboration. And it's kind of, you don't want to be too close because you get caught in the way of the machine, kind of the machine of making software. You can't do research anymore. You can't innovate. So it's kind of at the Goldilocks distance, and I'm enjoying that very much. We did release a whole bunch of things back in March. I'll be touching on some of these. Some of what I'll be talking about today isn't like what I was doing this month or last month. It's actually back a few months because we haven't released what we're doing. My work at the moment is not so much direct to open source as it used to be. But these are some of the things we've been working on. Copilot for docs, Copilot for pull requests, Copilot on the CLI, on the command line interface, and Copilot for a voice-driven experience for AI. So the common theme here is obviously Copilot. The common theme is about AI assistance for developers. Okay, in these different settings. So I'm going to talk about two projects, which first is about something down at the foundational level of how we think about these large language models, and then I will talk about a second project we did on code summarization. So first, and there's something very F# about this. There's a few connections with F# in this material. Way back when I first did some ML programming, so sort of OCaml style programming, the very first thing was trying to get a theorem prover to add up numbers correctly. And it was just unbelievable, this theorem prover, which was had all the rules of logic in it and could represent anything and do anything, and it sort of couldn't add up 1 + 1. And 23 years later, I'm sitting staring at these unbelievably powerful AI model components, and they also can't add up numbers correctly. And I kind of wonder where computing has gone, that we could have gone back around this loop. Okay, so we're going to be looking at getting large language models to deal with numbers correctly. So let's take a look. And this is released. You can take a look at this project. It's a relatively small project, but it's a lot of fun, and it's also a little exemplar project on doing GPT-4 programming. So please go and take a look. Okay, so there are lots and lots of related work in this kind of field about getting AI language models to equip them with calculators or to integrate calculation functions into their basic logic and so on. So the basic situation, what is the function that we implement, where you take some context of some kind, you take a question, you have an answer. That's the basics of chat. But the problem is that GPT-4 is absolutely terrible at numeric calculations. And it's, interestingly enough, something that comes out of this work is it's also pretty terrible at numeric comparisons and actually writing text, discursive text. So how bad is this? It's actually really bad in a way, I think. It feels to me that, well, let's talk about sort of different, let's take some examples. So here's a fail. This one is based on comparing financial documents. So if you take an example problem here, this is the example bit of text that has been generated. So can anyone spot the problem? So it's just nonsense, right? It's like 4.404 is indeed a larger absolute increase, but 2% is not a larger relative increase. Okay, so it's just like the second part, the parts in bold, relative 2% up 28%. It's just garbage, right? It's just getting the comparisons wrong. It's just formulating the text incorrectly. Most people by now know how these large language models work. It's just generating words and probabilities, and it decided that this sort of sentence is better, and it had committed down that path probably of saying this is relative and this is relative, and then it actually has to come up with the numbers, and it's actually surprised it didn't just fabricate the numbers to make it true in order but it didn't. Okay, so here's another one. This looks quite neat. It gets all the math correct. It gets all the symbolics correct in some problem, and then it says using a calculator we get this just to compute this function, except it's not the right answer, right? This is I'll use the little ghost symbol there for wrong, and this number here is just plain wrong. Okay, so it's terrible at numeric calculations, but there is a hope, right? These, and it comes from this code, AI for code kind of perspective, that these models may not be able to add up numbers, but they are amazing at writing code. So instead of getting it to think it can do the calculations, why not just get it to write the numeric calculation code instead? Okay, to get it to do what it's good at. Okay, write code. Okay, and it turns out writing 1 + 1 is a whole lot easier than working out 1 + 1 when you replace 1 + 1 with sufficiently complex numbers, with actually like big long decimal points, or in some, or they maybe date time values or something like that. But writing the code to add them up is actually simple. Sorry everyone. Writing code's really simple compared to actually running it. Okay, so let's try that out. We have a question and answer, but instead we're going to take the question and we say, no, don't answer the question. No, don't do that. We'll go write some code which will help you answer the question. And then we'll actually run that code and we'll get some answers, and then we'll fold in the question and the code and the answers, and then we'll say, now you can answer the question. Now you've helped yourself out. Okay, so I think this two-phase technique should really be incorporated into every GPT-4 request, really every primitive level GPT-4 request which is ever taking input numbers or ever involves writing numbers, should always, unless it's really known to be calculation free. Okay. Okay, so here's an example question, some random bit of text extract from some annual report. And then the question is at the end, what's the overall average and standard deviation per quarter over these 3 years in dollars or something? And okay, so that's a fail. These numbers are just incorrect. Okay, so we start building a prompt for this. We say do not answer the question. Instead, write some calculations and comparisons relevant. Do this by writing a code block, and it's interesting. What we're basically instructing it to do is writing an F# program, a well-formed program, bit by bit, that represents the calculation code. Now, we don't actually generate F# in this. It would work just as well to generate F#. We did Python and JavaScript. So definitions and calculations, and check the results, generate some comparisons relevant to the problem, and return all the results. So here's some more things. So interesting. You can start, now this is where this stuff is interesting, because programmers know that the names matter, right? The identifiers you use matter to help you reason about the code. Well, it turns out that also makes a big difference to the AI, that if you tell the AI to say, don't just write symbolic code, but actually describe, and this chain of thought kind of thing kicks in, that, use names like car count, speed of car in kilometers per hour, get it to put some information, extracting some information from that text and weave it into the program. You can also get it to write a descriptive comment, which helps it kind of keep track of its kind of reasoning of how things are going. You can also, for example, say include a unit of measure at the end of each comment. Now, I didn't do any computation with these units of measure, but you can get a feeling for where this can lead, that you can actually get it to put in units of measure, which you could then check separately. Even if you're generating Python code, you could sort of run the Python code or augment it in a way where the units of measure are being checked through the kind of system. So, but annotate these things, and if it's unknown, then you get some unknown. And now we say we don't want to generate arbitrary calculation code. We're trying to create something that's actually sound and trustworthy. If you let it start to write loops, it tries to solve all sorts of problems with loops all of a sudden. It tries to do too much. You're giving it too many toys to play with. And there's a lot of stuff floating around in the AI community now of kind of have lots of different they give the AI model like lots of different hammers to play with to kind of plan and hope that it plans its way through the process. But actually that's pretty dodgy because you're giving too many strong toys. So instead we make this toy quite weak, which is just right calculation, not arbitrary computation, but just numeric calculation code. And then we kind of say, don't do particular things, like don't do date-time calculations because they're really hard, right? We thought adding up numbers is hard. We all know date times are a complete nightmare because suddenly you find your date-time library can't represent dates before 1000 or before 0 AD or something like that, and somebody writes a history document and the date times don't work, and then you have time zones and goodness knows. But we do, in this particular example, we do say you're allowed to reduce to whole days, hours, minutes, and arbitrary seconds if you really want to give it a go, sort of break it all down. In the definitions things, this was for the JavaScript use, we say define labels using JavaScript const. Let's get rid of that mutation because the calculation code becomes more trustworthy when it doesn't use mutation. If you let it use mutation, it will. Okay, the model will say, yeah, it creates undefined things all over the place. And so yeah, no, it's got the very F-sharp feel in what we're generating here. And we say, well, you can use some data. You can have single-dimensional arrays. Don't do multi-dimensional arrays because even I, as a reader, always get everything confused and it probably won't work out too well in text. And in the calculations section, use const again. Define each label using an expression that references previously defined labels. They're very F-sharp. Order of definition matters. If you don't say that, it will just do forward references in its calculation code. It will put things in any old order it likes, probably based on the order that things came in the original text. And that becomes unsound. How are you going to execute that? You're going to have some separate phase to work out what's going to be what. Okay, so do not include the calculated values for the labels. That's actually important because it thinks it knows what the answer is. And it just goes and writes the answer instead. So you've got to keep telling it not to do things. It also really thinks it can solve equations, right? It's right. It's sure it can do algebra, and it kind of gets it right some of the time. You say, no, don't do stuff you're bad at. Just we want calculation here. No, well, I'll come to this point. If you avoid new assumptions in this section, it also gets division. You say use integer division. That is, it does make mistakes on that. And it also thinks it can round numbers, but you say no. Actually, the programming language is much better at doing rounding than you are. Just generate the rounding code. And it also thinks it knows the value of pi is 3.14. It happens all the time in the generated code because children are allowed to make that assumption in math tests. So you say, no, don't do that. It's wrong. Go and use the values from the library. So you see where this is going, which is lots of don't do this, don't do that. generate the more trustworthy code-based version of all of this. In the comparisons, we saw that it was getting that comparison wrong in that text, and so this is what comes out. So define additional labels relevant to the question using JavaScript const by labels and using comparison operators evaluating to single booleans. Don't include the calculated value. And I also did, you can check the report that we wrote up about this. We experimented with omitting a check section as well to check your work. So sort of what is a set of checks you could do to check that your answer is correct, like you do in high school math problems. This actually isn't that successful, and there's some interesting fails which I'll come to in a bit. Okay, so here's some example of the kind of thing it generates. That was that previous example. It does successfully extract tables from text very nicely and puts them into programming form. It successfully does calculations, even though like columns are in the wrong order here. It's just mapping it out as it was in the text. It successfully is generating some Python code in this case in order to calculate means and standard deviations here, and it's tracking the units correctly all the way through here. And then you actually run that code and things come out much nicer. And then you add that code, then you add the original question, you add the code, you add the text of the results, and that is enough to kind of stabilize the model to use those comparisons. Any uncertainty kind of gets eliminated in the final text generation, and it's in a much more, with all those things in the prompt, it's in a much more stable space to write the text that match. It's very hard for it to go write text that contradicts what's in the prompt. You've enriched the prompts. There's a lot of talk about retrieval going on in this kind of setting, that you have a question or a chat session, you automatically go and retrieve from the database all the facts that are relevant, stuff those in the prompt. It's playing the same role. You can look at this as a form of code generation and execution to do a form of retrieval or enrichment of the problem in the question. And so then it correctly gets rid of those hallucinations. Okay, so is this effective? Now, this is tricky because what we really want to be testing on is going to something like Bing AI or ChatGPT and finding all the cases where everybody has ever put in prompts and then numbers come out the end, and we want to check those numbers in actual real chat or real uses of these systems, because you can probably guess, given what we've done so far, you can make up problem sets which where this performs extremely well, where it's like 100% fail before and now 100% pass. So these are synthetic data sets where we just started formulating some problems in these various domains. And yeah, I mean, they are what they are, but it just does show that there are plenty of examples here. This like mortgage questions, rate of return, this, what is it, WACC is some capital of a company computation. These the raw calculation are all examples of things you really hope that technique that we've used will get it 100% correct, and that is in fact the case. You see that the date calculations, there aren't many date problems here, but it's much harder to eliminate the mistakes, which is why we sort of dropped that off and stopped focusing on that. These word puzzles were set, there's many more of these, 2,000 of these. It's a standard high school math set. Now, high school math is interesting because for the first 5 years, it's all about calculation. But then you start to do more and more algebra in word problems as well. You have to solve equations. And that's not what we're after here. We're really after the calculation subset, the kind of routine calculation subset. So we don't expect to, there's a whole lot of these we don't want to try and solve using this technique. Okay, so basically, you've got the idea. Calculation is hard for AI. It's probably never going to be really good at it. So in all the different functions that we consider to be calculation, writing calculation code is relatively easy. Computation is hard for AI. Writing code is easy. And so the AI bros definitely need that code after all, and they actually need reliable, logical, what they need is the emit of trustworthy, 100% trustworthy subsets of computation and logic, okay, and to integrate those into the AI systems. So I've covered most of these things. They're bonus topics that are covered in the report. There is some evidence in the report that actually that commenting your calculations does matter. We kind of did the experiment of turning off the emit of the comments, and it does help the AI get the calculations correct to have those weaved in to the code. So part of what I think of this is that the reason I focus on it is it's a strong theme running through F# that you want trustworthy programming, that when we say let x equal expression, you can trust that that expression has been, that initialization has happened and x has that value. So, you know, numeric calculation is sort of the hello world of this. And there's another perspective, which is that if you see a number in an output of ChatGPT, it's always rational in the sense it's always got an explanation. Okay, the Greek sense of rational, right? They liked rational numbers because there was a reason for that they existed. They were constructed by some way. And so numbers are always rational, and that it should be possible for every one of these systems to always explain what that number is. So I showed all of this to a friend of mine who works for for a consulting group, head of AI innovation in a consulting group. And he was saying, wow, what we're after is that code can now be explained, okay, that you're generating an artifact. You can imagine taking this technique to generate a spreadsheet from the problem, to generate a full Python program, and then that is the result of the chat session stored away for regulatory purposes or whatever else. And as part of that, every single number that's in the output should have its computation. It should have references for why those formula are the right formula to use. It should have references to where the numbers came from in the original text, or have they been made up from somewhere else or grabbed from some other source. Okay, so there's plenty of, so let's take a look at some problems with this. So yeah, this integration of chat data and programming is kind of coming very fast, much faster than I thought than in the last months. So chat isn't, the reason why ChatGPT exploded is because of this first one, chat for entertainment, right? Is that everybody started talking about it because it's so damn fun, it's so interesting, and so and it reaches this threshold where you don't just tell one person about it, you tell two people about it, and then you get this exponential spread all of a sudden where suddenly everybody's talking about it. The fastest adopted technology ever, I think. So chat for entertainment is great, and we all love it. But you might be doing this sort of chat for search against a document database or analytical question answering, or maybe this more subtle thing where you're actually doing technical creation or technical manipulation with the chat, that there's an object you're creating or an object you're manipulating with the chat. And I think the gold, really sort of the moonshot of all of this is, would you do your tax return with it, right? Would you trust the system to kind of fill in the numbers of that AI to kind of, and do all the calculations that kind of go along with that? And I'm wondering in this cycle of tax returns in the next year, whether we're going to get a lot of people, I think it won't be zero, right? The number of people who are sitting there with ChatGPT typing in the kind of stuff I've shown you so far and taking the questions, the answers, and pasting them into their tax return and trusting them, right? Some people are going to be doing that because they're going to give us their answer for where'd you get this number? It's wrong. They're going to say, well, ChatGPT gave it to me, and like, what are we going to do? There's related work, this code interpreter add-in for ChatGPT. It does use a similar kind of thing, was done at about the same time. It's not so much aimed at sort of soundness as the work, it's more aimed at kind of finding a balanced kind of augmentation of chat with code generation and data. It can reference some data files as well, but it's super interesting. There's also a ChatGPT plugin for Jupyter Notebooks and some other fun things. Just to see how this looks, you have similar kind of code generation coming out, more aimed at solution solving and arbitrary Python generation in this kind of case. Okay, so industry, as I was saying with that example before, is crying out for AI that can be trusted, explained, can generate trustworthy, recognizable, analyzable artifacts like spreadsheets and notebooks. And this is just a hint towards what we really need in this kind of domain. Now, interestingly, and I'm sure some of you are already thinking about this kind of technique can be applied to any language, to generating any language, including F#, but also any computational logic, any like theorem prover, proofs in a theorem prover. It can be generated, proofs in propositional logic. It can generate a DSL. It can generate a query language. Philip Carter, who used to work on F#, as part of the F# community, still he's using these kind of models to generate queries for the user. But also any use of a library or a service or a computational capability or a CI system or whatever you like. So you can say, for example, we saw the talk from Matthias on linear programming. There's no real reason why you can't generate a linear program as part of taking that text and getting the underlying linear program and executing it. And that augments the kind of computational capability. And the outputs, well, in this case we've had code, but you could also generate these proofs or spreadsheets or projects or tests or documentation, or perhaps tax returns at the extreme end of the spectrum. Now, but there is devil in the detail, and that is every single step where you ever invoke an LLM can introduce hallucinations. And a great example of this is hallucinated numbers in calculation code. So in an earlier version of what we did, look at these beauties. Here's the calculation it wrote. And then out of the middle of nowhere, it just filled in some numbers, right? This was the stuff that we were meant to be trusting, right? This is the stuff we want to be part of our explanation, and that gets submitted to the regulators for why we used ChatGPT to compare these two, or use, I shouldn't say ChatGPT, use an ML model to compare these numbers, and it's made up numbers. So now the prompting can get rid of that, and post hoc checking of that, or requiring annotations to say where did that number come from in that calculation code. Yeah, annotate again. Every single number is rational. Okay, so I think that hardened, reliable, trustworthy systems are totally critical, and all these themes come in: proof of evidence, reasoning, explanation, auditing, provenance, where to blame when things go wrong. It's all replays in this kind of domain of question answering for text. Yeah, so that raises lots of questions. What is evidence? What engines kind of establish trust? What ontologies or fact databases do we trust? How do we emit references to those? How do we kind of properly document assumptions that have been made about, say, the mortgage formula that's being used, or the time zones that are being used, and all the zillions of other assumptions that are woven into this kind of thing? Okay, so in the last part of the talk, I'll move on to a second project we did. The report for the first part is available. It is what it is. It was sort of a side project, but I just wanted to draw on the themes that relating it to F-sharp work, F-sharp's way of thinking, and sort of the more general questions it opens up about trustworthy chat. Okay, so I did another project doing this summaries in GitHub. I think we're heading quite rapidly to a world where most text associated with repositories is actually emergent from the repository, or an awful lot more of it is emergent from the repository, and it's sort of generated automatically. So just like we have content, and we're now used to, we don't manually create indexes of content anymore, we just search, then we have content and we sort of won't manually create anywhere near as much text or documentation. It will sort of just emerge. And so, for example, you can sort of automatically have abstracts or keywords or descriptions, or you can get table of contents, or you can get documentation or walkthroughs, or perhaps you want some slice. Walk me through the data layer of this web application, for example. What would the data storage used, or something you take? So you kind of want the documentation, but you want it to be along some slice of the program. Tell me about the exception handling in this repository. I'll write some text for you about the exception handling, okay? So we want to summarize along these various pivots, along these various topics, and it's got lots and lots of use cases in info panel or search or as initial text for human-authored descriptions or fixing up descriptions that exist and so on. And the more unfamiliar you are with a repository, with the content, the more pressed for time you are, or if you're especially if you're using these small factor devices, this content is all very valuable to these. It's probably less valuable to the people most familiar with the code. Okay, so we did a project, Copilot for PRs, which is released and it's waitlisted, but there's a lot of people using it today in enterprises and many other settings, which writes summaries of pull requests. So for instance, you take some pull request to this thing we were calling PR bot, and it writes what the bot actually does. It gets it quite well. And so that's taken the changes in the pull request. It's summarized every individual change in the pull request. It's collected up those summaries and written an overall and condensed that down. So you have the changes down to summaries of those changes, down to a small amount of text which captures the overall question, the overall purpose of the pull request. Okay, and then we did various things like generating the description here, then the user content is here, and then this section at the bottom, the more detailed explanation, and then sort of linking through to the changes of the code. And you can see the parts there that are automatically generated by Copilot for PRs. Okay, so what are we doing here? It's doing this hierarchical summarization, because we have all these various snippets of code, of changes. The delta means it's a change to some bit of code, and we summarize those up to the files, and we get a group of files with a summary of that, and then we feed those up to get the overall summary. So this can handle massive pull requests, and this is done in parallel and sort of churning it quite quickly, summarize up to the overall pull request and the final outputs. I won't go through the sample prompts of those. So, yeah, so what about hallucinations? It does make mistakes, especially in the purpose of the purpose of a change, or if it lacks sufficient context for the change. So we do label all changes with locators, and so any text it writes, it has to refer back to some particular change. It's not allowed to write text without giving evidence to say, yes, this bit of text relates to this locator. And that is really a good technique. It's about that thing about emitting proof. It's got connection to what we did before, that you're getting these LLMs to emit proof of the relationship. It's not proof, but it's at least making a connection between some of the input and some of the output. Hallucination is the worst when there's just small solitary changes. If it's given a one-line change, it'll just run on at length about what that thing might be and speculate and hallucinate about its purposes. So we pack lots of changes together, and we don't ask for long descriptions for small changes. We did get it to do a bit of fun as well. This was actually extremely popular with the team in our self-use. So for every pull request, we also wrote a poem about the pull request. You can read these ones. And we did sea shanties, I think. We did haikus. And we did, I think, Greek epics as well. We tried Shakespearean sonnets. It turns out love sonnets are really bad for code. It's really hard to write a love sonnet about, which is like, but sea shanties are great because it's all about working in together. It's all like, and what's interesting is that this kind of output actually seems to really help team cohesion, because somebody does a pull request and they say, look, the AI just wrote this poem, and they send it around to the team, and everybody's having a good laugh and a chuckle about and often it gets right to the point of the pull request, like this haiku at the bottom: command line PR bot engine added for automation ease, springtime coding bliss hash bang. It's probably not a well-formed haiku, but it's got to the essence of what that pull request was about. Okay, so we thought, well, we summarized pull requests, but what about if we actually want to summarize entire repositories? And these obviously don't fit in a single prompt. So we did the same hierarchical summarization for all the code in repositories from some particular SHA, and it runs effectively exactly the same process and gives some final outputs. And so, for example, and we applied this to some very large examples, taking all of the GitHub, that is the implementation of GitHub in the app directory. And it's great. It's actually a really good guide to it's much longer than this, the only controllers here. And app/API, app components, app controllers, and it's actually really capturing quite well what this software is actually about. And you can imagine surfacing this kind of automatic summarization in the UX. You could imagine a GitHub UX which has this kind of feature. This is actual outputs from the AI that's automatically summarizing. It might be incorrect. You want to label that very carefully as being an AI output, because people are obviously going to be nervous about putting probabilistic outputs into a user interface like this. I'm not saying this is going to be in a version of GitHub, because it's what if there's a mistake? It's a serious issue. But you get the idea of what might be there. You might put them in these little file panel things. This actually not filled in with AI output, but where you kind of get more AI output coming into the experience. But you can take this a little bit further, where you don't just summarize repository code, but there's no reason why you can't summarize issues. You can actually summarize all the issues in a repository. You can also slice those to say summarize all the issues to do with networking in this repository. And in principle, the AI can just kind of run up the entire information structure, write you a good piece of discursive text, and you help you and get on your way. Now, you could also put the deltas in front of this sort of thing and say, let's just look at all the changes in these things. Maybe the changes over the last week. What if you say, just write me, summarize all the discussions and what's happened this over the last week? And there's no reason why we shouldn't kind of take the same approach of this structure. And that's where we left that project. We've been moving on to other things which are really, really fun and fascinating. It's kind of got to do with summarization, but they've also got to do with generation and manipulation. And but we'll be talking about those more when we come up in our release cycle over the next few months. And that's it from me. And thank you very much.